A new supercomputer simulation animates the evolution of the universe. It's the most accurate, detailed glimpse of the early cosmos yet, researchers report. Radiation, blue, emanates from dense filaments of stars and galaxies, white, in this snapshot from a new simulation of the early universe. By James R. Reardon. December 2, 2022 at 10 a.m. The infant universe transforms from a featureless landscape to an intricate web in a new supercomputer simulation of the cosmos's formative years. An animation from the simulation shows our universe changing from a smooth, cold gas cloud to the lumpy scattering of galaxies and stars that we see today. It's the most complete, detailed, and accurate reproduction of the universe's evolution yet produced, researchers report in the November monthly notices of the Royal Astronomical Society. This virtual glimpse into the cosmos's past is the result of CODA-III, the third iteration of the Cosmic Dawn project, which traces the history of the universe, beginning with the cosmic dark ages, about 10 million years after the Big Bang. At that point, hot gas produced at the very beginning of time, about 13.8 billion years ago, had cooled to a featureless cloud devoid of light, says astronomer Paul Shapiro of the University of Texas at Austin. Roughly 100 million years later, tiny ripples in the gas left over from the Big Bang caused the gases to clump together. SN, February 19, 15. This led to long, thread-like strands that formed a web of matter where galaxies and stars were born. As radiation from the early galaxies illuminated the universe, it ripped electrons from atoms in the once cold gas clouds during a period called the Epoch of Reionization, which continued until about 700 million years after the Big Bang. SN, February 6, 17. CODA-III is the first simulation to fully account for the complicated interaction between radiation and the flow of matter in the universe, Shapiro says. It spans the time from the cosmic dark ages and through the next several billion years, as the distribution of matter in the modern universe formed. The animation from the simulation, Shapiro says, graphically shows how the structure of the early universe is imprinted on the galaxies today, which remember their youth, or their birth, or their ancestors from the Epoch of Reionization. The universe was a cold, dark place 10 million years after the Big Bang. Hydrogen gas began to clump together 100 million years later, forming dense regions, white, that gave birth to the first stars and galaxies, as seen in this animation from a new simulation of the early universe. Light radiating from the stars, blue, heated the gas around the galaxies as matter collected in a web-like arrangement. The pink bursts are high-temperature regions that appeared as some stars exploded. The galaxies and stars we see today lie along the filaments that resulted from the complicated interplay between matter and starlight, as the universe evolved.